thank you. Get out of my face. Oh, what is this? What the heck is this? Oh no. Are you looking for some good and entertaining past paper videos? Well, this one's for you. I cover the October-November 2025 paper 11 of Maths. This is an overview of the questions that I'm facing today, and boy oh boy, this question almost ate my soul. Alright, enough yapping, enjoy the video. What is going on, everybody? Today we're going to do the October-November 2025 past paper of Maths. So let's get right into it. So the first question, 3 cos 2x minus 1. Let's zoom in here first. What do we know about a cos function? This is how it looks, and the length of this is 360 degrees. This is the standard cos x. Now for cos 2x, there are going to be 2 wave cycles in 360, right? If 2 wave cycles live up to 360, then the length of one wave cycle is 180, and the period just means the length of one wave cycle, and that is 180 degrees. Now the question wants the amplitude, and this value is our amplitude. Basically, what it means is from the center line, what is the maximum and the minimum disturbance of our trigonometric function. This is going to be plus 3, and this is going to be minus 3. So our amplitude is 3. Alright, next question. Okay, so we're going to have to sketch this. So at first, let's see a normal cos graph, that is just this. Then we do cos 2x, that is like this. Then we do 3 cos 2x, that is a lot larger than this, and the maximum disturbance is going to be 3. Then we do 3 cos 2x minus 1. That is just the entire thing, just this baseline is going to start at minus 1. So keeping everything in mind, we are going to do the graph. Let me label the graph first. Okay, now what is our baseline? Our baseline is at minus 1, so let's draw it. Now our maximum point is going to be 3 more than minus 1, so 1, 2, 3. This is our maximum point, and then we're going to draw 2 cosine curves like this. So it's gonna go like this, and yeah, this point is going to be 3 less than this, so our minimum point is going to be over here, then again our maximum point here, then again a minimum point here, then again a maximum point here. So let's see. There we go, with a bit of a bump over here, but try to avoid these. Thanks. Get this out of my face. Okay, next question. Find the set of values of k for which this line meets this curve at 2 distinct points. Alright, so first our step 1 is going to be equating these 2 equations to get a quadratic equation. Then we are going to apply the b squared minus 4ac formula on that quadratic equation, which is b squared minus 4ac equal to 0. This is for 2 equal roots, and b squared minus 4ac less than 0 for 2 imaginary roots. And finally, b squared minus 4ac greater than 0 for 2 real and distinct roots. I hope you know this. And this question asked for 2 distinct roots, so we're going to use the b squared minus 4ac greater than 0 for here. Then from there we are going to get a quadratic inequality from that b squared minus 4ac greater than 0. Then we are going to solve that quadratic inequality that will contain k. Okay, so let's do the first step of the question, that is to equate these 2 solutions to get the points y equal to y. minus 3 is equal to x squared plus 2x. We are going to pull everything on the right side of the equal sign. Then we're going to pull everything from here to the left side of the equal sign. Now, this is our quadratic equation which we are talking over here. And we are going to use b squared minus 4ac greater than 0 on this bad boy. So here is our coefficient 1, this is our b, this is the a, and this is the c. So let's do b squared minus 4ac greater than 0. We substitute the values. Then we are going to expand this by using the formula that I'm showing on the screen right now. We're going to pull everything over here. Okay, is this factorizable? No, I don't think so. So let's use the quadratic formula, that is k equals minus b plus or minus root over b squared minus 4ac all over 2a. I love that song. Okay, let's substitute the values anyways. Let's simplify. Whoa, what is that? There was not a 2 over here. Okay, now what did I do over here? Let's take a look with the magnifying glass. Nice drawing. Anyway, so what I did here is this, we have this, right? We have this. We are going to introduce a square root on the denominator as well. That is root 4. That is 2. These two are equal. Then we're going to combine the fractions like this, and 48 over 4 is just 12. So that is how I got root 12. Okay, so our step 2 is done. Now we are going to solve the quadratic inequality. We are already trying to solve this quadratic inequality, and we have just obtained two critical values. The critical values are 2 plus root 12 and 2 minus root 12. So let's take a look at the graph. This is the graph of this quadratic inequality. This is a smiley graph because there is plus. This is a positive coefficient for k squared. If this was a negative coefficient, this will be a frown curve. So this point is 2 plus root 12 and this point is 2 minus root 12. What are we trying to find? K squared minus 4k minus 8 is greater than 0. When is this graph greater than 0? It is greater than 0 when it is on the left side of 2 minus root 12 and when it is on the right side of 2 plus root 12. So our two inequalities will be when k is greater than 2 plus root 12 and k is smaller than 2 minus root 12. Alright, that is our final answer. It was a nice question. I love this. 6 marker. Yep, nice. Alright, what do we have over here? Solve the equation x. Okay, so for a quick rule of thumb, what we are going to do is pull everything containing x on the same side of the equal sign. So let's do it. Let's rearrange it so that the x's are together and take this 4 over on the other side of the equal sign. Now, another quick rule of thumb, that is when x is on the base of the logarithm, we always want to take it out. So what I'm saying is when you have the x over here and another numerical value over here, we always want to take x out of here and put it over here and take this numerical value and put it over here. How are we going to do this? We're going to do this by using the formula that I'm showing on the screen. So that is how we interchange 5 and x over here. So let's do this over here. So we see log base 2 of x here, we see log base 2 of x here. So let's replace log base 2 of x with a variable like a. So it is going to be a minus 5 over a is equal to 4. Now we're going to multiply everything with a. a squared minus 5 equals 4a, and bring everything over here. Then pull a over on the left side of the equal sign by a squared minus 4a minus 5 is equal to 0. Now we're going to do some quick factorization. We have to think of two numbers that multiply into minus 5 and which add into minus 4. Exactly, it is minus 5 and 1. So a squared minus 5a plus 1a minus 5 equals 0. Then we factorize. So what did we get? A minus 5 is equal to 0, or a is equal to 5. And what is the value of a? The value of a is log base 2 of x equals 5, or x is 2 to the power 5 and x is 32. Wow, I totally got my colors all mixed up. Anyways, a plus 1 is equal to 0 and a is equal to minus 1. And what is the value of a? Log base 2 of x is equal to minus 1. So x is 2 to the power minus 1, or x is half. So these are our two solutions. Let me write it over here. Let's go. Oh my god, what is this now? Okay, so first of all, I see minus and minus over on the exponents. So by using the formula that I'm showing on the screen, we are going to pull the minus out and write the entire exponent thing as a division form. I don't know what I just said, but let's show. Now, according to the previous quick rule of thumb, we are going to pull everything containing x on the same side of the equal sign and everything not containing x on the other side of the equal sign. This is going to be x squared, e to the x squared whole square, and then 25e to the 10th power. We see a square over here. Let's pull this and make it a square root. You know what, we can just do it on this line. So what we can do is remove the square root and make 25 into 5, because the square root of 25 is 5 and half of 10 is 5. Now why did I do the half of 10 equal to 5? It's because, let's pull our magnifying glass again. What I did is, when you have something to the power something and you're trying to square root it, the square root is just a power of half. Now when we have exponents like these, we have to multiply them. So 10 times half, which is just a to the power 5. So that is how 10 became 5. Now, okay, the biggest question, how do we pull the x from the exponent and over on the normal region? I don't know what I mean by the normal region, but whenever in doubt, just take the natural logarithm because it solves all of your problems, including your relationship problems. Let's pull everything over here. Now, using the formula that I'm showing on the screen, the x squared just teleports from there to there. And 5 is a coefficient of e to the 5th power, right? So by using another formula that I'm showing on the screen, we are going to distribute this logarithm and write it as the addition of two logarithms. Now ln e is just 1, so we don't have to write it. This is just 1, so we can just ignore it. Now again, 5 is a power of e, so we can just bring the 5 from the exponent region and over on the normal region. And again, ln e is just 1, so I don't have to write that. Now there is an x squared, we take the root over there. So x is root over ln 5 plus 5. But guys, never ever forget the plus or minus here, because x can be both plus or minus ln 5 plus 5. Alright, that is our answer. Next question. Okay, what is this? Explain why this graph does not represent a function. Okay, so listen up closely. Come closer. This is what I like to call the vertical line test, okay? If a vertical line cuts the graph at more than one point, that is not a function. Well, this vertical line cuts the graph at 2 points, so that is not a function. So what are we going to write? We are going to write this. So basically, a vertical line intersects the graph twice, which is just basically more than once. So that is why this graph is not a function. Next question, please. Is this graph a one-to-one function? No, I will explain to you in a bit. Is this graph a many-to-one function? Let's see. Many values of x can lead to the same value of y, which lives up to the name many-to-one function. Many x values can have a single y value. So yes, this is a many-to-one function, and if this is a many-to-one function, it can never be a one-to-one function at the same time. Come on, you cannot be a boy and a girl at the same time. Okay, I should not talk about gender. Oh, whatever. Is its own inverse? Nope, I don't think so, because for it to be its own inverse, it has to be reflectable over the line y equals x, and I don't think it is reflectable. So let's just ignore that. Is this a one-to-one function? Yes, it looks like a one-to-one function to me, because every value of x has a single y value. More essentially, it is a straight line. It is a straight line, and every straight line is a one-to-one function. So yes, it is not a many-to-one function. Is it its own inverse? Let's see. Let's draw the y equals to x line. This is the straightest line I've ever drawn. Now, is this its own reflection? Yes, it is its own reflection. So it is its own inverse. Now, is this is this not a one-to-one? No. Is this a many-to-one function? Yes, because a single value of y can have 4 values of x. So it is a many-to-one function. Is it? No, I'm not even going to read this. No, get out of here. Is this a one-to-one function? Yes, it looks like a one-to-one function to me, because every single value of x corresponds to only one value of y. Yep. No, this is not a many-to-one function. Is it its own inverse? Nope, I don't think so. Next question. Okay, this is a hard. Oh no, this is a hard one, guys. Okay, let's see. Sine x for 30 to a. Root over x minus half for x is greater than half. Alright, terrific. It is given that the function... What? Function your girlfriend exists? No, your girlfriend does not exist. Find the value of a so that the domain of GF is as large as possible. You may use the information that sine 30 is half. Okay, thank you. So, let's see. There is your GF of x. First, we will look at f of x. Then we will look at g of x. Now, first, you feed something into f of x that should coincide with the rules of the domain of f of x. Then f of x will give out something from its range, and if that range coincides with the domain of g of x, it can only be fed into g of x. If it does not meet the requirements, it cannot be fed to g of x. And then after eating, the g of x will give out something from its range. Okay, so let's see. We are here to work with this one. What is this? This is the domain of f of x, right? So we want the domain of gf to be as large as possible. We want the domain of f of x to be as large as possible. From the question, we are given that the domain of g of x is x greater than half. So this is essentially x greater than half, which means the range must be f of x is always greater than half, right? Because if the range of f of x is less than half, it will fall out of the rules of domain of g of x, because it only accepts values which are greater than half. You get me? Now let's look at the trigonometric function sine x. We know that the max value of sine x is 1 and the min value of sine x is minus 1. But our range here is from 30 to a certain degree. Let's draw a line over here. This is our angle x. First, we are going to draw 30 degrees. Now, the sine of 30 degrees is half. What if we extend this over there? What about the sine of 60 degrees? The sine of 60 degrees is greater than half. Now, let's extend it even further to about 90 degrees. The sine of 90 degrees is just 1. We all know this. Now, if we extend this further, now what if we extend it to 120 degrees? This is less than 1 but greater than half. Now we extend this again, make it 150 degrees. It is exactly half. Now how did I know that? I know that by this thing. The sine of both of these angles are the exact same because they lie on the opposite sides of the same angle, right? So both of these are half. Now let's extend this further than 150, like suppose 160. Now this time it is going to be less than half. It's going to be less than half. But our domain of g of x only accepts values that are greater than or equal to half. So the maximum value of these angles is going to be 150. Got it? Which means our angle can only be from 30 degrees and up to 150 degrees. You get me? Because at 30 degrees it is half, at 150 degrees the sine of this is half, and at the middle, like around 90 degrees, it is exactly 1. And all of these values coincide with the domain of g of x, right? So this is our solution. Our solution is a is equal to 150. I hope you guys understood that. For the domain found in part 1, find the range of function gf. Now, one thing I want to tell you guys. This function and this function combine to make your girlfriend, right? So, the domain of gf is this and the range of gf is this. So, the extreme 2 points are the domain, the left one is domain and the right one is the range of gf. Now, for the domain found in part 1, this one, find the range of the function gf. So we are here to find the range of the function gf. Now back to here, what is our range of f of x? We found that our range of f of x is always less than or equal to 1. Let's just reverse this. Our range of f of x is this, and the domain of g of x must also be this for your girlfriend to exist, right? So this is our domain of g of x. Now, according to this domain, we have to find the range. Our g of x is x minus half. For the domain, x is greater than half but less than 1. So the minimum point will be half minus half, which is 0. This is our minimum point, and the maximum point will be 1 minus half, which is root over half. So our range of g of x will be, we gotta keep in mind that the range of g of x and the range of g f of x is the same, because this is the same as the range of this. Right, so this is our final answer. Determine whether the function g squared exists. So basically, g squared x is the same as g of x. So first, the orange g of x, and then the red g of x. So first, we have to feed something into this g of x, which must be inside the rules of the domain of g of x, and it will spew out something from its range. And if that range coincides with the domain of g of x itself, only then it can be fed to another g of x, and then from there it will spew out something from the range of g of x. Our domain of g of x is x is greater than or equal to half from here. Now let's find the range of g of x. The minimum point is going to be half minus half, which is 0. We just put half on the x. We just substitute half over on the x in this equation to get the minimum value. This is the minimum value, by the way. The maximum can be anything. Like, seriously, the maximum can be anything. Like, if this is like a big number like 69, it will be 69 minus f, and that is just going to be a lot greater than 0. Now let's see. This is 0, right? But the domain of g of x is always x greater than half, right? It does not accept values which are less than half, and 0 is just less than half. So this does not work at all, which means the function g squared does not exist. Now, how do we write this? We write this by writing that the range of g of x does not coincide with the domain of g of x, and that is our final answer. Whew, this question was lengthy AF, man. I don't want to do anything like that anymore. Okay, what is this? The first term is 3. Oh, we have to keep in mind that it is an arithmetic progression, so there is going to be a D. The sum of the first 10 terms. Now, what do we know about the sums of arithmetic progression? The formula is n over 2 times 2a plus n minus 1 into d, where n is the number of terms. So for the first thing, this is going to be 10. And for the second time, this is going to be 5. So let's see. It said that it's 4 times the sum of the first 5 terms. I mean, this times 4 is equal to this, right? Which means this and this are only equal when the right side is multiplied by a big 4. Now, let's put in the values of a, which is just 3, so we can directly say that 2a is basically 2 times 3, that is 6. So let's simplify it further. We bring 5 down over here, so that is just going to cancel out to 2. We distribute the 2 on the 2 terms. There we go, d is equal to 6. That is our final answer. Next question, please. Okay, we have a mingle over here, which is an arithmetic progression trying to mingle with a geometric progression. So, first, we take note of the arithmetic progression. The first term is going to be a. The second term is going to be a plus 2 minus 1 into d, that is a plus d. The fifth term of the arithmetic progression is going to be a plus 5 minus 1 into d, which is a plus 4d. Then, for the geometric progression, the first term is going to be a as well. The second term is going to be a times the ratio r. R is like random ratio, like the common ratio here. And the third term is going to be ar to the power 3 minus 1, that is ar squared. Now, given in the question that these are equal, and these are equal. So let's cook up some equations. First one is a equal to a, bruh. Second one is a plus d is equal to ar. Now what we want to do is pull everything containing a on the same side of the equal sign. We're going to take a common, then we isolate the a. Now I don't like this minus over here. Now I'm going to multiply the numerator and the denominator with minus 1, so that this minus and this minus cancels out, and the minus over here reverses the 2 terms over here. So this is one thing. Now for the second thing, again we pull everything that contains a over on the same side of the equal sign. We take a common, we isolate the a now. Now let's break down this by the difference of 2 squares, right? This is 1 square minus r square, so let's break this down. Now again, I want to get rid of this minus over here, so let's just multiply both of the numerator and the denominator with minus 1. So this minus cancels and the terms over here change sides. there we go. We got two equations, a here, a here. Let's just put a equals a, that is d over r minus 1 is equal to 4d over 1 plus r and r minus 1. So let me teach you something. Zoom in. When we have same things on both sides of the equal sign, that is d on the numerator and d on the numerator here over as well, we can cancel this. And we also have r minus 1 over here and r minus 1 over here, so we can cancel this as well. So we cancel this side, we are remaining minus 1 over here and 4 on the numerator and 1 plus r on the denominator. We pull this over there, we get r plus 1 equal to 4, which means r is equal to 3. Did we get our answer? Find the common ratio. Yes, r is equal to 3. That is our final answer. Thank you. Easy one. X squared minus 5x absolute. So what this means is x squared minus 5 can be both plus 6 and minus 6. So from here we get two equations, that is x squared minus 5x equal to 6 and x squared minus 5x equal to minus 6. So let's solve both of these equations individually. And this is by far the easiest question I have seen on this paper. Everything else is just horrible. X equal to 2, x equal to 3, x equal to 6, x equal to minus 1. Thank you. Now, differentiation. Our good old friend. Let's consider this as u and let's consider this as v. So basically we have u over v. Now let's recall, how do we differentiate something that is as a fraction? Yes, we use the quotient rule, that is v du dx minus u dv dx over v squared. So let's substitute the values. This is v e to the 1 minus 3x times the differentiation of u. The sine x becomes cosine x and the cosine x becomes minus sine x. That is just simple differentiation, and then we just copy u and then we differentiate v, that is this times the coefficient of x, that is minus 3, and all over v squared, that is e1 minus 3x whole squared. Now I'm not gonna simplify all of this, bro. This is enough for 4 marks, I hope. Okay, now integration. Now let's distribute the integral over here and here. Pause. We can do this, but can we do this? No, because there is a square on tan and we did not learn this at school, so that is not a way to do this math. Now we have to be a little cheeky here. 1 plus tan squared theta is sec squared theta, right? So we can just replace this with sec squared 3x. Now we know the integration of sec squared 3x is just tan, and the coefficient of x comes under this, and don't forget the plus c. Bro, a lot of people forget this, but this is very important, and that is our final answer, I hope. Okay, simultaneous equation. Oh man, I miss these a lot. Actually, not really, I hate these. X equal to 1 minus 6y, and here is x over 2y, 4y over x, and this. We will substitute the value of x over here. So let's combine the denominators, and we have to multiply this over there and multiply this over there. We break this down using the formula that I'm again for the 1000th time in the video showing on the screen, and we take the denominator and multiply it over there. As this is a minus 1, I'm gonna switch these. What is 36 minus 8? That is 28y squared minus 12y plus 1. Then we're going to distribute 2y over there. 12y squared minus 2y. Now we subtract 12y squared from both sides. 28 minus 12, it is, I think, wait, no, that is 16, right? Yeah. Oh my god, I'm tripping now. This. Now this is minus 10y, right? Yeah, okay. Let's factorize this. So we are getting 8y minus 1 equals to 0, or 8y equals 1, or y equals 1 over 8, then 2y minus 1 is equal to 0, or 2y is equal to 1, or y is equal to half. Alright, we have got these. I'm super happy, man. Then let's substitute both of these values over here. Wait, what happened? Yeah, over here. And then we normally solve for x. Then another solution, that is x is minus 2. So our pairs are x equal to half when y is equal to 1 over 8, and x is equal to minus 2 when y is half. Beautiful answers in my opinion. Next question. The diagram shows the velocity time graph for a particle moving in a straight line. Okay, so this is a straight line and the particle, suppose it starts from here, its velocity is negative. So the right side is positive velocity and the left side is negative velocity. It first has negative velocity, so it goes to the left, goes to the left, goes to the left, and then primarily it stops over here. The velocity is 0 at time something between 1 and 2. Then it changes direction and goes to the right side because the velocity is positive, so then it starts going there. Okay, so that is the entire storyline. On the diagram below, sketch the speed time graph. Now, one thing I know, that speed can only be positive because speed is scalar, but velocity can be positive and negative both. So what do we do to the negative velocity? Yes, we just flip it upwards like this. So let's draw the graph, which is like this almost, and instead of going over there, we are going to reflect it over here. Very nice. Okay, next question. It is given that the velocity time graph is a part of a quadratic curve. Oh yeah, it really looks like a part of a quadratic curve, right? The gradient is 0 when time is 0, meaning the gradient is 0 when t is equal to 0, when time is 0. Now, what do we know about the gradient of a velocity time graph? The gradient of a velocity time graph is the acceleration of that thing. That means that the acceleration of the particle at time equals 0 is 0. That means the acceleration at time equals 0 is 0. Very nice. Now, it says that it was a part of a quadratic curve, right? Which is ax squared plus bx. We can also take the derivative of this thing, which will give us the equation for the acceleration, that is 2ax plus b. The plus b does not exist because, as I said, the graph starts from 0. So our graph is only 2ax, which is a straight line, right? It says only to sketch, not to plot a graph, so we don't need to find the value of a. We just need to know the shape, and the shape is a straight line only. Thank you. Get out of my face. Oh, what is this? What the heck is this? Oh no. Okay, the diagram shows the curve x squared minus 9x plus 18 and the line L, which is normal to the curve, and blah blah blah. Okay. First, we want to find this portion, right? How are we going to find this portion? First, we are going to find this portion, and then we are going to subtract this portion, right? Now, how are we going to get this portion? Can we directly get it? I don't think so. We have to divide this into two areas. This triangle, which I'm going to color code into green, plus the red curved region. So let's get right into this. First, we are going to find this point and this point. We can do this by easily solving the quadratic equation. That was relatively easy. So x is equal to 3 and x is equal to 6. So here x is 3 and here x is 6. Now let's find the x coordinate of this line. Oh, it is written x equal to 5. Okay, bingo. Now let's find the entire region first, which is going to be the integral of the quadratic equation from the point 3 to 5. Let's see. We are going to raise the power from 2 to 3 and divide 3. We're going to raise the power from x to the power 1 to 2 and divide 2. Then we're going to raise the power of x to the power 0 from 0 to x to the power 1. Okay, so let's just put the limits. Wait, whoa, not 3 to 5. If we do 3 to 5, we are going to get this area if we do 3 to 5, but this is not what we want. We want this. So that is 3 to 6. We want the entire this region. I'm really sorry, people. Okay, let's put the values. There is going to be a minus over here. I think I'm too tired for this. So the minus turns into a plus and... Okay, so we got the area of that region to be minus 9 over 2 units square. Then we need to find the area of the blue region. That is the combination of the green region. Let's find the green region first. We need to find the coordinate of 5 and something over here. We know the coordinate here, and that is just 5, 0, and that is 3, 0. We need to find the coordinate over here. We can do is directly put 5 over on the axis of the equation of the curve. That is minus 2. So the length of 3 to 5, that is 2 units, and the length of 0 to minus 2 is 2 units. That means the area of triangle is going to be 2 units squared. Now let's find the area of the red region. We are going to do is find the integral of 5 to 6. So this part of the quadratic equation. Okay, we got it. Now, how do we find the area of the shaded region? The shaded region is going to be the 9 over 2. Then we subtract 7 over 6 and 2 units squared. So our answer is going to be 4 over 3 units squared. That is our answer. Very, very nice. Okay, permutation of n items taken 4 at a time. So the permutation of n items we are taking 4 at a time is equal to 1/6 of the number of 2n items taken 3 at a time. Okay, we have to prove this. So we know that the formula of npr is just n factorial over n minus r whole factorial. So we are going to use this 2n minus 3 whole factorial. Now what we can do is we decrease 1 from the factorial and we can write another product. What do I mean by that is we can write 5 factorial as 5 times 5 minus 1 factorial, and we can write that as 5 times 5 minus 1 times 5 minus 1 minus 1 factorial. Would you look at that? Voila! So with the newfound knowledge, we can write 2n factorial as 2n times 2n minus 1 times 2n minus 2 times 2n minus 3 whole factorial, all over 2n minus 3 whole factorial, right? And we can just cancel these two and write... One thing I want to say that we can cancel this and write 3 on the denominator, then write n here, take 2 common over here, and yeah, I want to pull everything over here on the top. We can break n factorial and give n times n minus 1 factorial, then have n minus 2 factorial, then have n minus 3 factorial, and when we get to n minus 4 factorial, we already have that in the denominator, so I don't want to write that. As I said at some point in the video that we can cancel these, which are on the same position on both sides of the equal sign. This is on the numerator, and this is also on the numerator. So what we are left with is this. Let's multiply these and take the 3 over here. We distribute the 3 and then we subtract 4n from minus 15n and get minus 19n. Then okay, this is gonna be plus. Yeah, this is kind of falling off a cliff, but yep, we proved it anyways. And hence find the value of n. Okay, so to do this, we are first going to multiply 3 and 20 and get 60. So 60 is our thing. We have to find two numbers that multiply to 60 and two numbers that add to minus 19, minus 15 and minus 4. So let's use them. Or n is equal to 3, n is equal to 4, and n is equal to 4 over 3, or n is equal to 5. We take the integer one because n cannot be a fraction, because you cannot have a fraction of items at the beginning. Okay, final question. Relative to an origin O, the position vectors of A, B, and C are OA, that is 1 unit to the right and 7 units upwards. 1, 7, you get A, and then 7 units to the right and 4 units upwards to get to B. And then with some scalar value k, we go 2 units. We go 2 units rightwards and 1 unit upwards to get to C. We don't know the value of k. We have to find the value of k. Okay, so what is going to be our step 1? We have OA, we have OB, we are going to find AB because we need this over here. Then we have OC, OA, and OB. This is going to be a step 2. Then we will find, somehow we will find AC, and then we will find the ratio of A and B. But at first, we have to find K over here. Alright, so let's get right into it. OA plus AB is equal to OB. So AB is equal to OB minus OA. So AB is just 7 minus 1, 6, 4 minus 7 is minus 3. So AB is that, and we want to find AC. So let's substitute the values. We want to find AC, and OC is just K and 2K. We just multiply K with both of these, so AC is, this is our AC. Now, given that C lies on the line AB, meaning this is the line AB, and C lies somewhere over here. Now, if we take a look at this, that the gradient of AC is same as the gradient of AB, because all of them are collinear. So let's try to find the gradient of each of these. And the gradient of AC will be the same as the gradient of AB. There we go, we got the value. K is equal to 3. So OC is equal to K 1, 2, or it is 3, 6. That is great. Alright, so AC is just 3 minus 1, 2, and 2 times 3, that is 6, minus 7 is minus 1. And AB is 6 minus 3. So AC and AB can be obtained by dividing these vectors. I don't know if we can divide these vectors, but you get 1 is to 3. So AC is to AB is equal to 1 is to 3, and that is our final answer. Thanks for watching this freaking video. Bye-bye.